Good afternoon, everybody. Nice seeing you all back to the live talks of Eurostruct. We have an exciting afternoon today, a very interesting speaker, the one coming from practice, not from academia itself, which is a good change for a time. And with no further ado, I would like first to present myself. My name is Rade Hajdin. I am a professor at the University of Belgrade, at the same time president of the infrastructure management consultant company in Zurich, Switzerland. My co-chair of this live talk is André Angelin, and please introduce yourself.
Thank you, Rade. I am André Angelin. I'm head of the section for bridges at the Civil Engineering Institute in Ljubljana, which is called also ZAC. And my professional focus is into pushing new technologies, principles into a bridge assessment process. So that's from my side.
Thank you, André. Our speaker today is Thomas Moser. Thomas Moser did his bachelor in University of Applied Sciences, Carinthia. He did his master's at Technical University of Graz, and he did his PhD at University of Natural Science Resources and Life Sciences in Vienna. He's now working in an Austrian motorway and expressway operator, ASFINAG, being responsible in the Department of Asset Management, including development of the maintenance strategies and the preparation of the forecast for long-term budget requirements. He also worked prior to that in a different civil engineering company, and his expertise is also mirrored in the title of his talk, Managing the Infrastructure Asset. What we are going to hear today in this talk is roughly an overview of the assets of ASFINAG and the way how to manage this infrastructure. And with no further ado, I would like to pass word to Thomas. Thomas, the podium is yours, please. Thank you.
Thank you, Rade, for your short introduction. As Rade already told, my name is Thomas Moser, and I'm working for ASFINAG, which is the Austrian operator of motorway and expressways. And I'm responsible, my responsibilities in the Department of Asset Management are the maintenance strategy and the forecast for our long-term budget. And let's start. I hope the slides will switch. Yes, perfect. Today, I want to give you a short overview about the following topics, some general information about the ASFINAG so that you understand and see how the ASFINAG is working, and the Department of Asset Management, followed by our maintenance strategy for our assets, for our main infrastructure assets. And last but not least, I want to give a short overview about the recalculation of bridges at the ASFINAG. Not really in detail, but I want to give just a general approach how we deal with old bridges and how we recalculate them. So general information about the ASFINAG. What is the scope of our activities? The scope of the ASFINAG is to operate, to maintain, to build, do the toll collections, and do the financing of the motorways and expressways in Austria. For this, we have four main companies which are responsible for these tasks. For example, the building company, the Baumanagement company, is responsible for providing a safe and reliable network, and is also responsible for building new assets and maintain the existing assets. The service company, the ASFINAG Service Company, and the ASFINAG Alpenstraßen Company is responsible for operating this network. And the tolling company, ASFINAG Maut Company, is responsible for collecting the tolls which have to be paid for using the motorways and expressways in Austria. And in addition to these four main companies, there are three minor companies at our holding which deal with commercial or the European toll service. We handle about 26 billion kilometers of total traffic per year with a road network of 2,249 kilometers. We have 42 motorway operation and maintenance facility and 9 traffic management centers which are responsible for monitoring the traffic and set some actions if necessary. For example, speed limits or lane closure or something like this, or rerouting if we have problem on our network. And furthermore, we have 6 toll stations for our special toll routes. These are, for example, the Karawankentunnel, Tauern-Katschberg, or the well-known Brenner. And all these tasks are provided with about 3,000 employees. So let's get to our main assets. What are the main asset categories next to bridges? First of all, we have the pavement, which is one of the most important asset class of all infrastructure owner. We have a total length of 2,249 kilometers, which means 12,200 lane kilometer, and with an area of approximately 43 million square meter of pavement and asphalt, where we can say 1/3 is asphalt and 2/3 is asphalt and 1/3 is concrete pavement. The next important assets are the bridges. We have 5,818 bridges with a total area of 5.8 million square meter, which means that our average bridge is about 1,000 square meters tall. Due to our topology in Austria, we have in relation to our net length, a high amount of tunnels. We have 393 tunnels with a length of 402 kilometers. And the next assets are also very important assets, but we call them minor assets. So we have 74 galleries, which are often connected with our tunnels, and 1,855 retaining walls, and approximately 4.1 million square meter of noise barriers. And this area is still rising. So we expect a little more in the near future. How ASFINAG uses its revenue, as I told before, to use the motorways and expressways in Austria, you have to pay a toll. And in 2020, we have revenues of about 2.2 billion euros, which were spent according to the diagram. We used about 50%, so that means 1 billion for reconstruction and maintaining our assets, and about 21% we spent for taxes, fees, and dividends, and another 20% for the operation, the toll collection, and other things. And at least 9% of our revenue were spent for our interests. So 1 billion euro for our network. On this slide, we have a short overview of the main projects we have done 2021. For example, we have a very huge new tunnel project, the second tube of our Karawankentunnel, and a very interesting big construction site in Vienna at the A23. It's the Hochstraße St. Marx. It goes right through the city of Vienna, and there was a amount of about more than 100,000 square meter of bridge maintenance, which costs about 130 million euro. So this is one of the most expensive bridge construction in 2021. And we have a few new construction large projects, for example, the S7 direction to Hungary, and the Linzer motorway and expressway A26. So what are the core areas for the building company? We have, on one hand, we have new construction and renovation. So the ASFINAG Baumanagement carries out all construction measures for the new construction and the maintenance of the motorways and expressways. And it also builds access, exit lane, service station, and all stuff like this. And on the other hand, we have needs-based project development, which means that the Baumanagement company plans project based on the requirement of the people and the economy. And these plannings are always process open and takes into consideration the interests of all those involved. And last but not least, we have our asset management, the Department of Asset Management. And in the framework of maintenance management, infrastructure facilities are permanently monitored and checked. And we ensure that roads, tunnels, bridges, and all the other assets are efficiently maintained with the greatest possible level of safety. So these are the three main areas, the core areas for the construction company. To understand our budget needs and our budgetary needs for the future, I want to show you the development of our network. As we can see that we have a high increase of our network due to the 70s and the 90s, which leads to an increasing expenditure due to this extension. And when we look at the chart, we see that all assets which were built before 1985 are relevant for maintenance and reconstruction now. So we have a high amount of assets and a high amount of areas which are relevant, budget relevant now. All other assets, so let's say after 1985, are not relevant at the time, but they will be relevant in the future. So this is a very important thing. And on the right-hand side, we see the average age of our assets. There we can see that the bridges, for example, are in average 38, 39 years old, which means that the first big maintenance is just done or is shortly before. It's always a big impact on our budget. And when we look 30 to 40 years into the future, there we have a huge renew time for our bridges in the network. In detail for our bridges, it means that about 40% of our bridge surface in our network is built between 1970 and 1990, and so that means that the average age is about 38, 39 years. And on the right-hand side, we have a distribution of our bridges combined with the condition, where we can also see this high amount of bridges in the years between 1970 and 1980, 1990, this area here. And we have a combination between the distribution of the building year and the condition. And there we can see that all the bad condition and very bad condition, 4 or 5 condition rate is are the older constructions. So in the last slides, we saw how the network was developed, and to be able to maintain an aging infrastructure, the budget and the budgetary needs must also rise. So as we can see here, the budget for maintenance is constantly rising. These numbers are just the budget for maintenance, not building completely new roads and completely new infrastructures. As we can see here, until the year 2021, we have budget we used, and from the year 21 into the future, we have the planned budget. For example, we used in the year 2020 about 192 million euro for maintaining our pavement and 207 million euro for maintaining our bridges. And in the future, these amounts are still rising. Year 2025, 232 million euro for pavement and 283 euro for our bridge maintenance program. The forecast shows us that we will reach a steady state for our budgetary needs at about 1,000 million euro in the year 2056, after a huge peak at 2048 with a price basis of 2021. So, but what I have to say is that the current increasing prices are not considered in this forecast. So nobody knows if these numbers are still valid or if there is increasing to these numbers. So the next slide, the Department of Asset Management. The activities of the Asset Management Department are divided into two main sections. We have on the one hand, we have 4 different units which are divided regionally. We have 4 regions for structure maintenance management, and those units are responsible for the inspections, the checks, the technical expertise on site. And one main topic is the definition of maintenance measures for our assets. And on the other hand, we have the team engineering, and they are responsible for developing the maintenance strategy and reporting and the coordination between the ministry, which is the owner of the ASFINAG. And in addition to these topics, the colleagues from engineering are also responsible for the technical support on site and the coordination of the participation in guidelines and organizing the internal inventory documents for all our assets in our network. So I told you something about our maintenance strategy. To fulfill the targets of the company, a maintenance strategy was developed in the past based on the mission of the ASFINAG. We divided it into 3. We developed 3 different levels to manage our goals. And the first level focuses on the main strategy, which is anchored in the mission. And the main one of the main strategies for asset management is that we offer our customers a maintained and repaired network and use the available resources responsibly. So this is our main topic, and from this on, we developed our maintenance strategy, and we divided it into 3 different columns. The column network safety, network availability, and the planning reliability. And the next level under the strategy level is the management level, where we defined different key performance indicators. Behind every line, for example, bridge condition, pavement condition, is a key performance indicator which will be monitored and where we have target values to reach. For example, the structural safety, we have to have condition defined measures for our structural engineering buildings if we have a condition rate 4 or 5. These defined measures could be a building measure, reduced inspection interval monitoring, or organizational measures as lane closures, for example. And in one of the next slides, I will explain the KPI bridge condition a little bit in detail to understand what is our focus with these KPIs. The third level and the last level is the operational implementation, where we can find our tools to achieve these defined goals. On the bottom, we have our maintenance, our asset management manuals. These documents include very important information for every asset class. So for every asset class, bridges, pavement, noise barriers, retaining walls, we have these asset management manuals. And in these documents, we anchored things like the standard life cycle, the inspection process, or some other important information and strategic points for every asset class. Something. Okay. The reason why this KPI in the column, why this KPI is in the column network availability is because with a high amount of bridges in a bad or a very bad condition, we are not able to provide an available network according to our targets. And we want to manage our projects, and we don't want to be managed by our projects. So we try to limit the bridges in a bad and in a very bad condition. And actually, we have about 7% of our bridge surface in condition 4 or 5, but just one bridge is in condition rate very bad, and this will be reconstructed next year. So 7% in condition 4. So what are the management tools we use to manage our assets? We distinguish our tools in two main groups. And we have on the one hand software tools for operational activities and software tools for reporting and analysis. On the one hand, we have the infrastructure management tools, a tool for the visualization of the pavement condition, and some other project management tools, for example, project request management and project management system. And on the other side, we have software tools for reporting and analysis. For example, the pavement management analysis tool, DTeams, and a common Microsoft tool, Microsoft Power BI, a business intelligence tool, where we are able to show information from different databases and combine information from different databases and combine data so that we can gain knowledge from the different data and the different information. This slide shows the front end of the infrastructure management tool. On the right-hand side, you see a view of a handheld, which is used for our inspections and for our checks on site. So the colleagues are on site with a tablet or an iPad or something like this, or another handheld, and do the inspections and the checks via iPad online. And then we transfer all the data into our database. And the front end in here is the program ProOffice, and all the data are organized with this program. So this is our main tool to organize inspections, checks, and to organize our data. And for the pavement, we have a tool for the visualization of the pavement. This slide shows also the front end of this software, and we have the possibility to visualize structural index, comfort and safety index, and other condition indexes of our pavement. And in the future, we will be also able to show information of our construction program so that we can directly see the pavement condition in the affected areas or in the planned maintenance areas. And one of the most powerful tools and most used tool in the ASFINAG since I think 1 or 2 years is Power BI. And here you can see especially a dashboard which provides some information of our bridge portfolio. On the right-hand side, we can see the amount of bridges in different conditions. For example, we have 3,213 bridges with a condition rate good. And on the left side, we have we can make this information more precise to split the condition on the different corridors or on the different lanes, the different routes in our network. So for example, we have at the A1 approximately 500,000 of square meter bridges on the whole track. And there you can also see the different condition states, and with endless possibilities to combine information and gain knowledge. Another thing, for example, is to show the different materials of our bridges. On the right side, we can see that about 3.2 million square meter with pre-stressed concrete, which is Spannbeton in German, and about 2 million square meter of reinforced concrete, which is Stahlbeton. And the two dashboards were just a small abstract of dashboards we have to manage our assets in the maintenance program. And with the next slide, I want to show you a really interesting thing. By combining different databases, as I mentioned before, for example, the condition and the construction program, we are able to show the ministry our strategy for our bridges. For example, the asset safety focuses on grades 4 and higher. For example, these maximum 10% of our bridge surface, and shows that all bridges by combining different databases, different informations, we can show stuff like this. So, and the next thing, the calculation of bridges at ASFINAG. Let me start again with a short diagram regarding our bridge portfolio. As we can see, a lot of bridges were built between one of the big questions we always have. And for these, I want to make a definition of the different terms. So the first term I want to define is the maintenance, which means a structural measures to restore the target condition. So this is very important. Then we have the refurbishment or an upgrade, which means that we have structural measures to improve the load-bearing capacity. Then the next term is a renewal. It's very easy, the destruction and the replacement of an existing bridge. And the target condition is the planned condition at the time of construction. So the important terms for us is the difference between the maintenance and the difference between an upgrade. So when do we recalculate? In general, we have the principle of trust. So we trust those people who calculated and designed the bridges in the past. Existing structures have been tested and used for many, many years. And we have conclusions on the real behavior. And it's a proven system. So why should we recalculate all of our bridges? But sometimes there is a need of a recalculation in case of statically relevant damages. For example, during an inspection, during some checks, we see statistical relevant damages, statistical problems, and something like this. There is a huge need for a recalculation. Before inventions in upgrading the structure, this is why I want to define those terms. We just need to recalculate when we want to upgrade our structures. With a standard maintenance, in Austria, there is no need to recalculate our bridges. Which is therefore the assessment of the load bearing capacity of existing bridges. And if we have to recalculate our bridges, we have 4 different steps to do so. So the first step is a recalculation according to the current regulation, current Eurocode. So for example, if everything is fine with this bridge, step 1, check everything is done. But in most of the time, we can't fulfill all the requirements. So then we get to step 2, the recalculation of the bridge with an updated data. So we are able to use actual material parameter of steel or concrete if we verify these updated material data via tests. And we also are able to reduce the partial safety factor on the resistance side if we prove the real dimensions on the side of the system. So check the length, the width, the spans, something like this. If we do so, we are able to reduce the partial safety factor only on the resistance side. And if we fulfill all requirements, check, we are done, and the recalculation is finished. If not, we have 2 more steps to do. Or we have the possibility to do 2 more steps, and the step 3 is an assessment of the reliability according to the Eurocode. And step 4 is then accepting a reduced level of reliability. The last step, or unfortunately, step 3 and step 4 are really hardly used at ASFINAG, but I hope that it will be used in the future. So maybe it's a problem at our side that we don't want our consultants to use it, but I think in the future it will be used more often. Step 3 and maybe then step 4. So this was a brief and short overview of the assessment of load bearing capacity of existing structures. And I think it was very quick. I'm at the end of the presentation, and I hope I could give you a brief view inside the ASFINAG and how is the ASFINAG organized and how we manage our assets, so that we have now enough time to answer some questions. Thank you.
Okay, thank you, Mr. Moser, for this very nice presentation. I'm sure there are a lot of questions now, and one is already here at the chat. I don't know if everybody sees it. Mr. Roberts Ozins asked a question which was in a way already answered, but I think it would be nice to elaborate it. And Mr. Ozins questioned, what asset management system program are you using? And if it is a commercial or off-the-shelf system, or how do you solve this issue at the organization?
Our infrastructure management tool is a customized program which is off the shelf. So we bought a software, license of the software, and we customized it to the needs of ASFINAG. And Power BI and all these analyzing tools are off the shelf Microsoft programs.
Okay, I hope that answered the question. Any other question, please speak up, or preferably put a question into the chat.
It should be on chat, right? And
should be in chat, yeah.
Up to now, I don't have another question, or maybe I can ask a couple of questions, maybe one at first step. There is I saw on your slide the term corridor planning.
Yes.
Can you please elaborate on that? How do you do that? How do you do the corridor planning, which is a hot topic, I think, for every agency?
Yes, corridor planning is a long-term planning at ASFINAG. So we have different corridors. For example, the Donau corridor, which goes from Salzburg to Vienna. And when we talk about corridor planning, we always look at the whole corridor to manage our maintenance program and don't have too many construction sites one-on-one. And we also check the whole corridor if it's possible to do the construction site as we want to. So we check the year the network is built, the condition, and make a plan for the next 30 years. So we look at the maintenance which we need now, and we also look at the maintenance which we need next. And with this information, we generate a plan for the whole corridor for the next 30 years, with just main measures. not small things, just main measured. And this we try to do of all of our corridors, the west, the Donau corridor, and the south corridor, for example. So this is what we understand in corridor planning.
Based on this question, do you have a minimum interval between the measures, I mean time interval, that's what I think, between the measure of the same corridor?
The plan is when we are now on kilometer 5 at A1, we don't want to be there with a big measure until the next 10 to 15 years.
10 to 15 years, okay.
Yeah.
Okay.
This is our target with for example, next big measures.
Andre, your question?
Yeah, I was wondering to ask you, what is your approach for maybe reducing the indirect costs in the big reconstruction or maintenance work on bridges, for example, to minimize the traffic jams because of that, for example? What is your approach? How do you I don't know, adapt that in the procurement process for the contractors or something like that? I don't know.
A huge cost problem is to provide all lanes during a construction site. So this makes huge costs in the motorways and expressways. So, but we want to have an available network, and so this is a very difficult to say what's possible to reduce these costs. We can say, okay, let's close line, let's close our side of the road, but then we have costs on the other side. So this must be shown for every project. You have to evaluate what is possible with the traffic on the street to reduce the cost, to close lane, to reduce the costs.
Thank you. There is one question that you are definitely going to like very much. Are also coming from Roberts. Are your existing bridge bearing capacity recalculation are based on reduced EC alpha coefficients, or are you using some other type of loads?
No, when we recalculate our bridges, when we want to upgrade our bridges, we have to use a minimum alpha coefficient of 0.8. So it's not necessary to upgrade our bridges to 1.0, but if we upgrade, we use at minimum 0.8. These are the two coefficients we use. But we actually in Vienna we have a bridge way motion system where we try to measure the real traffic and to generate the real alpha coefficient on the bridge, and this is what we use now for an upgrade until on the end of the lifetime. For example, we have bridges where we just need 0.6, 0.7 the alpha coefficient for the load model 1, and this is one way we try actually for our recalculation.
Just to be clear on that, alpha coefficient you mentioned is both alpha Q large as well as alpha Q small.
Yes.
Okay.
Both.
Andre?
Okay, thank you, Rade. So maybe I have from other perspective a question related to your bridge inspection methodology. Are you currently satisfied with your methodology? Do you have any plans to update or novel it? Or
actually, in the last years, we have a huge update of our inspection and checks. 3-4 years ago, we have checks with hard copy on site with paper drawing, and then put everything on the computer and much office work. And now we are trying to do all the work on site with our tablets. So process is still going on, but I think we're in a good way, and I'm very happy with the things to be done actually with our inspections and the construction. but it was really hard work to get there and to ask people to work with handheld and not with the paper write system and stuff like this.
Yes. And do you think that now, let's say, do you play with an idea about the digital asset management? However you are able to imagine what this definition is, in a sense that, I don't know, integration of BIM concept in that process. Do you think that that is the next step?
For us, the next step is how should I say it? A red line through the life cycle of an asset, a digital red line through the life cycle. We need from the beginning on, when we construct a new bridge, we need all digital in the way we need it. I don't need every small detail of an bridge, every small detail they need by when they build it, when they maintain it, when they construct it. But I need in general some attributes and some informations which will be needed the next 30, 40, 50, 80 years. And this is, I think, the next thing, that we start digital. Then we have checks, controls in a digital form, and with life cycles and the results of checks, we can generate the right maintenance, the right measure, and then we put the measure on site, and then we can get back the information what has to be done, and so on until the end of the lifetime of the bridge. I think this must be the next step to get a red line through the life cycle of our bridges. Not BIM, not really detailed
the full
things.
history.
This is, yes, the full history of the life in detail.
There is a question we just popped in. Are you using some permanent monitoring system on your assets?
Yes, we use some permanent monitoring systems, but this is the next huge thing. We don't have those monitor systems stored in a database so that I can tell you at bridge X we have this system, at bridge Y we have this system. But yes, definitely we use, but we use it only at old bridges and the bridges with a poor or very bad or very bad condition.
Okay, we have another question. With the age of your infrastructure, do you maybe have particular challenges such as hot joints, post-tension corrosion, etc.?
We have no special issues. We have the issues of all road infrastructure owners, for example, chloride with the corrosion. But we have now we have no special issues with our bridges. Just the main problems. So there's nothing with the pre-stressed structures or something like this.
Okay.
Let me ask you another question here. You correctly stated that you have a principle. You're using a principle
Yes.
of trust. You believe that the bridges have been designed properly. And the second issue there that you presented in your slide was the bridge was used for such a long time, so it should be okay. Now, at the same time, you said that you are using updates, right? In your, I think the level 3 or level 2? Level 2. Level 2 use updates. Now, my question is, since you know what this bridge has sustained in the past, do you use this data to update reliability or not? I mean,
no, unfortunately not.
Unfortunately not. Okay.
Unfortunately not. So we just use the updated data of the resistance side, because concrete, steel, the measures, something like that. But we don't use the knowledge of the past. What you mentioned.
Okay.
Unfortunately not.
Okay. Andre, any other questions?
I have also another question, which is related to the let's say bridge assessment. You already mentioned how you, let's say, deal with incorporating reduced alpha by measuring with the bridge system, but But for example, what about the seismic load? Even though the Austria is not like heavily seismic region, I would say, but do you find in your, let's say, reliability analysis or bridge assessment analysis also this load relevant when you reduce the traffic load?
Seismic loads are not relevant for recalculation. The bridges in Austria, they are relevant when you design it, when you plan a new bridge, for sure. But if you do the recalculation, the seismic loads are not relevant.
Are not relevant or not considered?
Both. They are not considered according the norm, according the regulation.
Okay.
So we don't have to.
So this is our Austrian regulation, right?
Yes.
Or okay.
Yeah. For new construction, of course, we have to use Europe.
Okay.
For the recalculation, we don't have to consider them.
There is another question just came in, and is: are you able in ASFINAG manage overall? I think overall probably. No, excessive load probably, it's not real. Vehicle movement as a circulation are done by some contractor. I believe this is a special transport meant here, the overweight transports, right?
Okay.
And you know what that you have to give a permit to special transport to move along your network. And the question, I believe, are you doing this recalculation on your own, or you have a contractor to do so?
We have recalculations on our own until I think 60 tons, and if the heavy loads are over 60 tons, then we have a contractor. But we don't have to pay for this recalculation. If the heavy loads want to drive through our network, they have to do the recalculations and show us that there's no problem for the bridges.
Who is paying for accompanying police? You need a special transport normally need police in front and behind, right? In this case, so they are paying for that as well, I believe. Okay, yeah, that's what I meant.
Yeah.
Okay, I think there are no more questions from the audience. Maybe
there is another one. Sorry,
go ahead, please.
It was addressed directly to me, so I guess that's why you not see it. And the question is really specific in a sense. The question goes: what type of sensor do you use for permanent monitoring? If maybe no.
Oh, that's really specific.
Specific, yeah.
I can tell you the exact sensors what we use, but if necessary, I can get this information from our colleagues and provide it. My contact was shown at the last page of the presentation, so please contact me, and then I can give you the presentation, the information.
Okay, great. Thanks for that. I'm sure.
On my side, there are no more questions. How about you, Andrei?
I have maybe just one. The last, it's really like a short question, which is more operatively from the bridge inspection perspective. So, how many bridge inspectors are roughly engaged in the all bridge inspection activities in Austria? In ASFINAG.
In ASFINAG?
Yeah.
In ASFINAG, we just do the checks by our the minor checks by our own, and we have, I think it's 70 employees which are responsible for those works. But they do more, not only the checks.
Okay. Yeah.
But about 70 people are responsible for these tasks.
Great.
Well, I guess so. We are coming to the end. It was very interesting talk. I think discussion was also fruitful. I would like to thank you, Thomas, for interesting talk today, and of course we look forward to see what's going on in ASFINAG in the future. You are a very exciting company, probably the cutting edge of European bridge management. So we are really looking forward to it. With no further ado, I would like then to go further and acknowledge our sponsors or facilitators. This is in the first place the University of Minho, who is providing us a platform. Then FIB, Fédération Internationale de Béton, who is also our partner. And finally, the design has been done by Butik, the company, Portuguese company that is also producing leaflets. Finally, I would like to say that this talk is being recorded, although with some interruptions as far as I'm concerned.
This is what I heard during my presentation.
Exactly. So I guess Sergio is going to stick it together somehow and put it on the YouTube, so you can also put forward the link to the YouTube and you can listen to your talk again, Thomas, if you want to do so, or somebody else, which would be much more reasonable, of course. Our next talk is going to be on July 26th, and is going to be by Professor Tracy Becker. She is the professor, University of California at Berkeley. And it's going to be about the topic that Andre just raised just a couple of minutes ago, performance and application of seismic isolation in structures. And I hope that we are going to have the same audience or even large audience maybe on 26th July, given that this is also vacation time. So this, I would like also to thank Andre as my co-chair. You did your job very well. And again, take care, stay healthy, and see you soon. Bye-bye.
Bye-bye.
Bye.